So we've got a question here. It's asking us to find the area of these two shaded regions on this graph. Now, we've got two lines going on here. We've got y equals 5 minus x, which is this straight line here. And we've got this curved line here, which is a quintic, which is y equals 5 minus x to the 5 over 4. Now, we'll see here there's a point here on the y-axis at x equals 0. Now, if x equals 0 for this one and this one, then y equals 5. So we know that this point here is at 0, 5. But what we need to find is this point and this point. So if we want to find the area, what we'll need to do is take the integral of the difference between these two graphs at these 2 points and find out a solution for that. So what we need to do now is find out what these 2 points are here. So what we'll do is we'll set them equal to each other. So if you've got 5 minus x to the 5 over 4 equal to 5 minus x. And then what we do is solve for x here, and we should find these points. Okay, now 5 minus x to the 5 over 4 equals 5 minus x. Well, both sides contain a 5, so we can cancel those out straight away. And then we've got minus x to the 5 and minus x. So what I can do is I can turn those two to both positive as well. So a minus and a minus, multiply both sides by minus 1. I'll end up with plus x to the 5 and plus x. Okay, so now what I'll do is let's bring this x onto this side and set it equal to 0 and see if we can find some solutions. So now we'll have x to the 5 over 4 minus x, so that's bringing this onto this side, equals 0. Okay, now let's get rid of this denominator here of 4, multiply everything by 4. So now we'll have x to the 5 minus 4x equals 0. Okay, now let's factor out an x. So we've got x times, well, this gives us x to the 4. And taking x out of this one, we're left with minus 4. So that all set to 0. So now we've got a situation now we've got either x equals 0 or x to the 4 minus 4 equals 0. Well, we've got our x equals 0 is a solution because we've got this point here on our graph. So if x is 0, we've got x to the 4 minus 4 equals 0. So let's see if we can take out this x to the 4 minus 4, see if we can take a factor of that. So let's write this as x to the 4 minus. Now as we've got a minus here, and this could be a squared and this could be a squared, we could have the difference of 2 squareds here. So let's turn that one into 2 squared and rewrite this one into x squared and set that to 0. Then we've got the difference of 2 squares. So now we can be left with x squared minus 2, x squared plus 2, and that will equal 0. Okay, so now we've got x squared minus 2 equals 0, x squared plus 2 equals 0, and x equals 0. So let's write that up here. So x equals 0, tick, we've got that sorted, no problem. That's already here. X squared minus 2 equals 0. Let's have a look at that. So let's solve for x here. So x squared equals 2, hence x equals plus or minus square root of 2. So that will be our x coordinates of these points here. So this one here, that's going to be positive. So we've got positive root 2. We don't know what the y is. And here we'll have negative root 2. And again, we don't know what the y is. Okay, we don't know what the y is, so we'll leave it like that. Okay, so now what about this one? X squared plus 2 equals 0. So x squared plus 2 equals 0. X squared equals minus 2. Well, now we're into complex numbers. So there's no complex numbers in this question. So this one here, we don't need. So this is what we need, and that's what we need. Okay, so now we've got our points on our graph for our x values. Now we can take this off the board, and now let's go and find out what the area of these shaded parts are. Okay, so now we've got our points on the graph where our x points are, where these graphs meet. We've got our x equals 0 as well, and we've got x equals plus or minus √2. So now we're going to find out the area of these two shaded regions. Now normally what you do is you take one function and subtract the other. So let's just write that. So 5 minus x to the 5 over 4, and subtract 5 minus x, so that's our two functions. So the difference between the two functions, and integrate from a to b with regards to x. Now in this case, we'll see here our y equals 5 minus x to the 5, our quintic, it's less than 5 minus x for negative values of x. But for positive values of x, our quintic is larger than 5 minus x. So to just simply subtract the two, that's not going to work for us, because this one then will be a negative value and this one could be a positive value, depending on which way round we write the two functions. Now I've chosen this way here. This way can work, but also the other way round can work. So it doesn't really matter which way round we're going to write these functions, because what we want to do is to find them individually. So what I would suggest is here, if we find the absolute value of these two, because we don't want a negative and a positive, we can't have a negative area, find the absolute value of the areas and then add the two together. So let's just do that. So then we've got minus √2 to 0, and then find the absolute value of our integral. Now if we do that, that will work great for this one. What about for this one? Now for this one, our parameters will change. It will go from 0 to √2. Now if you flip the parameters on an integral, all you end up with is the negative version of the other integral. But as we're taking the absolute value, they will both be the same. So what we can do is, if we take the absolute value of this integral and double it, that will give us this shaded area and this shaded area at the same time. So let's do that. So take this big line out here, write a 2 in front of it, double it, and then that should give us our result. So let's go straight in, integrate from 0 to √2, double it, and this is just a polynomial which we can integrate nice and straightforward, no need for any substitutions. So let's integrate this one. So 5 minus x to the 5 over 4 minus 5 minus x. Well, we can simplify that. So we write this down as 2, integral from 0 to √2. These 5's, 5 minus 5, they're going to cancel. And then we're going to have minus x to the 5 over 4 minus x with regards to x. So minus x will give us positive x. And then we subtract x to the 5 over 4 dx. So that's a more straightforward integral than what we had before. Okay, so now we can go straight in and integrate this. We've got our parameters and double the absolute value. So let's go straight in for that. So 2 times absolute value, well, integrate x, that's going to give us x squared over 2. Raise the power by 1, divide by the new power. And same for this one. So minus x to the 5 becomes x to the 6. And then divide by the new power. So put a 6 in the bottom here. 6 times 4, 24. And that's from 0 to √2. And absolute value, and now we can calculate our result. Now when x is 0, this just becomes nothing. So all we need to do now is to calculate our value at square root of 2. So we've got 2 times Now, our x squared, when we square that, we get 2. So we've got 2 times root 2 squared over 2 minus root 2 to the 6 over 24. So root 2 to the 6 over 24. Okay, let's work out what that is. So now root 2 squared, that just becomes 2. 2 over 2 is 1. So that equals 2 times 1 minus root 2 to the power of 6. Well, root 2 is 2 to the half. Let's just write this here. So basically we've got 2 to the half to the power of 6. Multiply the powers, we just basically got 2 cubed. So we've got minus 8 over 24. 8 over 24 we know is a third. So 1 minus a third, this here is just 2/3. So that just becomes 2/3. So now we've got 2 times the absolute value of 2/3, which is 2 times 2/3. So therefore we've got 4 over 3. So the area of these two shaded regions is basically, let's write it here, area equals 4 over 3. So whatever units you're using, that's what you would have units squared. Okay.